Good afternoon, everyone. I am Mr. Ish. Thank you for joining me. Center of mass calculation, or the centroid calculation for the region of space bounded by these two, y equals x and y equals root x. You see, you have that specific region of space. What is the center of mass from 0 to 1? If you do the intersection point, equal those to each other, you'll always have 0, 0 and 1, 1. Now, because we have two curves over here involved, the formula differs a little bit. You have the x value of that center of mass coming here, 1 over a to b. Now you can have x, but you'll have f of x minus g of x dx. You see how there's a little bit of a change because we have two curves involved. The difference of those two curves will bring you to your x value determination. What about the y value? It'll be 1 over a, again from a to b. Now you have here f of x whole square minus g of x whole square all over 2 dx. You see the little bit of nuances that have come into play here simply because the question is now slightly or a degree higher in terms of difficulty. That's the formula modification that you have to keep in mind when you have situations such as this. Two functions involved, hence you're seeing like that formula come into play. We have to determine the area, so let's do it. Area here with regards to x is equal to, from 0 to 1, your top boundary curve minus your lower boundary curve, which is root x minus x dx. You can integrate all of this. You'll have x to the 1 over 2 minus x. You have to integrate that from 0 to 1 dx. You'll have x to the 3 over 2 over 3 over 2 minus x square over 2 from 1 and 0. But because you have a 0 and a 1 involved, you're really looking here at 2 over 3 minus 1 over 2, which is 1 over 6. So the area over here is 1 over 6. But look, area is 1 over 6, but it's always the reciprocal of that. When you do the reciprocal of that, you're getting here a value of 6. You'll always be plugging here a value of 6 because it's 1 over a, which is 1 over 6, which is equal to 6. So now we have this, and we have the modified formula simply because we have a system of equations or functions here involved, not simply a curve or a line with regards to the axis, but two lines or two curves which are enclosing a region of space. But we've determined this area. Now we have to determine the x and the y values of that center of mass, and we will do so. It won't be any stretch of imagination to do that. Let's do the x right here, the x value. You know you have a 6, which is 1 over a, 1 over 1 over 6. From 0 to 1 you have x, f of x minus g of x. This right here is my f, here's my g. Top boundary, lower boundary, you should go with that. You always want to remember this part right here. The f of x here should be greater than or equal to g of x. Indeed, this right here, root x, is greater than g of x. In terms of what you see, just graphically, it's higher and it's larger in terms of its outputs. You see that. For this domain, we have 0 to 1. You have x to the 1 over 2 minus x. All of this times x dx. You can open this up. You'll have 6, 0 to 1. You'll have x to the 3 over 2 minus x squared dx. When you integrate this, you have 6. You'll have x to the 5 over 2 over 5 over 2 minus x cubed over 3 from 1 and 0. Because of the limits 1 and 0, it's not a stretch of imagination. You're really looking at 2 over 5 minus 1 over 3. That's what you really have. We have to do this. Common denominator is 15. 5 goes in 15 3 times. 3 times 2 is 6. 3 goes in 15 5 times. That's 5. And you have a 6 sitting out here. You have 1 over 15 times 6. You'll have 6 over 15. But what's 6 over 15? Simplified, you'll have 2 over 5. I've determined my x value here. I'm just putting it here, 2 over 5. We'll save that. But again, I highlight the fact here, we have a region of space bounded by two functions. You have to utilize that. It's not just a function or line against an axis, but it's a function or line against another function and or line. The y value of the center mass determination is not hard. It's pretty routine. You just have to remember that this is the formula you're using. You'll have 1 over a, which is 1 over 1 over 6, which is 6 from 0 to 1. You'll have f of x whole square. F of x here has been determined to be root x because it's higher in terms of its outputs, in terms of its relationship. Root x square is just an x. G of x was given the designation of x because it was less in terms of its relationship. X square, well, you have this 2 in the bottom. Don't forget this 2 divided by 2. This divided by 2 can come out here and make that 3. You're looking here from 0 to 1, x minus x squared dx. Now this is not hard. You have 3 times x squared over 2 minus x cubed over 3 we're looking at it from 1 and 0. But because of the nature of these limits, they're so easy, you're really looking at 3 times 1 over 2 minus 1 over 3. A half minus a third is a sixth. 3 times 1 over 6, which is a 1 over 2. That tells us we have over here an x and a y value of the center of mass, correspondingly 2 over 5 and 1 over 2. But I want to clean it out for you and put it out for you right over here. The center of mass calculation bears the following result: 2 over 5 comma 1 over 2, which is really this value, your x value and your y value correspondingly. 2 over 5 would be a 0.4, as you know. It would be, if this is a 1, here's a half, it would be somewhere here. In terms of half, it would be right here. Here'll be your center of mass. Again, remember, this picture is not drawn to scale, but it falls somewhere right here in terms of the center of mass, or the center, or the central point of this region of space between the two curves. Again, the calculation differs here slightly from the previous two calculations of the videos on the same subject, simply because you have this coming in here, f of x minus g of x in both instances, but it falls within the same basic format of the equation for the x value and the y value. Always remember this little peculiarity which can come into play. And that's the topic for this video, and this video has been completed for you. Thank you for watching. Have a good day.